Well, hello and welcome, folks. I'm Bill Simpson from UAF here, and we're just all coming into the room here, so we'll wait a second to let people get in and get settled in our meeting today. Looks like we've gone live on Facebook now, so welcome everybody. Welcome to this meeting of the Fair Air Study, the Fairbanks Wintertime Air Quality Study, or you may hear some of us also calling it the Alpaca Project, which is related to Alaskan Layered Pollution and Chemical Analysis Project. This is a big project here in Fairbanks where the international science community has come together to try and understand air quality under cold and dark conditions. And we have more than 40 people in town right now studying air quality at multiple sites around Fairbanks, trying to understand the unique conditions we have right here. One of the things that's really unique about this study is we decided to answer a really commonly asked local question, which is, what's the air quality like inside my house? And the way we're doing that is by making measurements, state-of-the-art measurements, inside a house and outside of a house, so that we can compare between these two and try and address that question. So that's what we've got going on here. As I said, I'm Bill Simpson. I'm from UAF here. We have many people from other universities, and I'm going to hand it over now to Professor Peter DiCarlo, who is from Johns Hopkins University, and he's going to give you an introduction to what we're doing at the house.
Thank you, Bill. I will share my screen and get started. Thank you all for joining. We're excited to be here and share some of the work that we're doing. So I'm going to give a brief introduction on some of the work that we're doing in a house, as Bill mentioned, in Alpaca, and then I'm going to hand it off to all the people who are actually doing the work, the students and postdocs who are, taking the data and analyzing it, and so we can hear from them. So just to give you guys a quick overview, we want to thank, first of all, always want to thank the funding that's making this possible from the National Science Foundation and the National Oceanic and Atmospheric Administration. And then down here, you see all these different universities that are participating in this project at the house. And you're going to hear from most of these groups tonight talking about what we're doing. So I think many of you are familiar with outdoor air quality, and you can see in this, this is one of the sites that's measuring outdoor air quality in Fairbanks, and there are monitoring stations to measure outdoor air quality throughout this region. Outdoor air quality is something that's regulated. We have national ambient air quality standards to understand what pollution levels are acceptable, and when we're too high, things like burn bans go into effect to try to minimize some of the sources that contribute to that high level of pollution. The nice thing about outdoor air quality is you can always check online if you know where to go and see what the air pollution levels are like. I want to contrast that with what we're doing in this house. This is a picture of the garage. You're going to see a more live video shortly. Indoor air quality is not regulated in the same way that outdoor air quality is. But especially when it's minus 30 degrees outside, it's where we're going to be spending most of our time. And so some of the science questions that we're trying to answer in this study are, what are the differences between outdoor air quality and indoor air quality? And how does outdoor air quality influence indoor air quality? Also, in your house, you're doing things. So how do our activities, whether we're using a wood stove or a pellet stove, or we heat our houses differently, or we cook, how do those activities change the indoor air quality in our home? So those are some of the just general questions we're asking. And to do that and to look into those questions and to try to answer them, we're making these very detailed state-of-the-art measurements, both inside the house, it's what this kind of yellow cross thing is looking like, it's like an inlet in the house, and also outside. And we're doing that with some instruments. We're switching back and forth between measurements about every 10 minutes, and some instruments take longer to make measurements, and they're doing more like an hour kind of time scale. But basically, we're measuring simultaneously both outdoors and indoors, and understanding what the differences are and what the similarities are. Part of that allows us to answer questions like, how much outdoor air pollution gets into our house through cracks in our windows and doors? There's a little bit of infiltration, we call it, that happens naturally, and we want some ventilation to happen. So this is a good thing in some ways, but we want to know how much of that outdoor air pollution on a bad air quality day is making it into our home. other questions that are really interesting for us is when it's, minus 30 degrees outside and it's 65 degrees in a house, how does that temperature difference between outside and inside, when that air does come inside, how does that change the air pollution? How does it change the way some of the gases or particles behave when they come into a house? And so these are some scientific questions that we can start to answer with the measurements we're making. And then I mentioned before activities. We've got a pellet stove in the home that we're in that we've been turning on and off and trying to understand how the use of a pellet stove may change indoor air quality. We're also doing things like frying up some chicken breasts and seeing how the act of frying in the kitchen may also impact the indoor air quality, and trying to understand from that perspective. So I'm gonna give you this kind of preview picture again. These are some of the different instruments that are in the garage. And I think I'm gonna hand it over to Ellis, who's also at Johns Hopkins University, to give you guys a little video tour of what's going on in the garage right now.
All right, thanks, Pete. Hi, everyone. Like Pete said, I'm a researcher at Johns Hopkins, and I'm also in the garage currently. I'm going to try to give you a little tour. Maybe Bill or Pete, can you nod if my sound is coming through okay? Okay. So yeah, I just kind of want to give a tour of our home-turned laboratory here in Fairbanks. This is the inside of the garage, and I guess you've seen from Pete's picture and from these pans that I'm doing, there's a whole bunch of kind of complicated instrumentation in here that doesn't usually live in here that I'll mention in a second. But first I wanted to show you, this is our portal into the home. And so these tubes going through this door, don't worry, we replaced the homeowner's door with a fake one so that we could drill through it. But that's how we're getting air from inside the house to the machines that are in this room. And then we're kind of doing the same thing going outside. So you can see this tube, oh God, this tube behind me is going through a garage door. We also made a fake garage door so we could drill lots of holes through it. You're probably noticing some of those. So that's how we get air from outside inside. In the case of some of the instruments, both of these indoor and then outdoor lines run into a box like this. And there's some valves and machinery inside this box that sort of toggles between indoors, outdoors, indoors, outdoors. And we're constantly doing that so that we can both compare indoors to outdoors sort of in real time, and then also understand the long time behavior of all the indoor air and then all the outdoor air. And I just want to illustrate that a little bit here. Here's an instrument. This measures a few kind of gases that you'll be well acquainted with: carbon dioxide, carbon monoxide, methane, water vapor. And you can see that for 10 minutes at a time, which is sort of each of these different levels on this graph that you're seeing here, we sample from the inside and then we switch to the outside and switch back. And so our data has these sort of steps in it, which sort of allows us to measure two environments sort of at the same time. Like I said, we've drilled holes through this garage door, which is behind me. It's sort of barely recognizable as a garage door, with coolers that have been mounted onto here and giant pieces of ducting and blower boxes that have been installed. One of the challenges that we've had here in Fairbanks, believe it or not, is the fact that this garage is really hot, and cooling it down to temperatures that wouldn't impact the health or the kind of the ability of our instruments to measure properly was one of the big challenges early on. And so we had to figure out ways to dump heat out of here, which is what this blower box is doing. This blower fan is doing. We've got another one of those. And then we also wanted to get cool air in. So cool air is coming into here and just blowing on this instrument so that it can stay at a temperature that is healthy for the pumps that it uses. So I don't know, that's sort of an overview of, without getting into the specific instruments that we're using, each of which is, you know, takes a person's full-time work or even a team of people to operate properly. I think now we're going to go around and talk about some of those pieces of equipment. But I sort of wanted to make sure everyone understood sort of the general setup here in the garage and how we sample from inside the house and outside.
Great. Thanks so much for the tour, Alice. So we thought we'd pause a couple times. Does anyone have any immediate questions right now? You can type them into the chat if you have them. We're going to circle back to questions at the end. So if you think of a question later, please type it in there. If it's to a certain group that presents, you could try and identify the measurements of the gases or something like that as an identifier so we know which group can address that question. So I'm going to look in the questions that came from Facebook also. So I don't see any there. So I think maybe we should go to the next, Pete.
Yeah, I think Damien is going to give us a little tour of the PTRMS, the proton transfer reaction mass spec.
Great. So I guess I'm going to have Ellis follow around the camera. I don't know how we, there we go. Perfect.
Ellis, so, for me, it's kind of choppy. If you hold it in a single place for a while, it might be a little better.
Yeah, so this instrument here is called as Pete said, a proton transfer reaction time of flight mass spectrometer. And this instrument is, it seems really complicated, but it's really not all that much. Essentially, we use electricity to put charges on water and allow that water to mix with our gases that we're pulling in from either indoor or outdoor. And so that those are over 2 hour gases that we're trying to analyze. And because they're charged, we're able to filter them and get the samples that we want. Based on how long it takes them to get to our detector, it tells us what size of molecule that is. We measure molecules, hundreds of molecules at one time. We have a mass range of 0 to 400, which is pretty robust for very, very volatile species that evaporate readily. And so a lot of these chemicals, many of you have heard of, like benzene, formaldehyde. So all of these chemicals are come from many different sources, and we're trying to understand what sources they're coming from. And so being able to measure hundreds of different gases at one time allows us some insight into the sources of those gases. So as Ellis is showing my display here, at the red and blue lines up on top, so those are the different signals for all of the different gases that we're measuring, from very small to very, very large gases, or fairly large gases, and that are present in our daily life and very important to us in terms of causing cancer or many other problems, even potentially exacerbating other health conditions. Yeah, and that's pretty much it. I'm really excited to see what comes out of this. I'm really excited that the community is excited about this project as much as we are.
It's Damien for sharing the PTRMS. I think we had Carol, who's going to talk about another instrument in the garage that also does some gases and also makes measurements of some particles too. So Carol, you're up.
Yeah, can you hear me okay? All right. So I don't know if Alex is going to show, he's behind my instrument over there. It's a little big of an instrument, but this is the SVTAG, which stands for semi-volatile thermodesorption aerosol gas chromatograph. It is a big name for a big instrument, But the idea behind it, it's pretty simple, although the measurement is a little bit complicated. So we all know that the pollutants, both outside and inside, they are composed by thousands of different compounds. And these compounds, they can go back and forth between the gas and the particle phase, depending on temperature. So the instrument, the SVTAG, is designed to identify these compounds, basically can tell the chemical composition, and it can also give information about whether these compounds are in the gas or in the particle phase. The SVTAG can also quantify these compounds, telling how much of these specific compounds are in the gas phase, the particle phase, or both phases. So when we are sampling alternated indoors and outdoors over time, the SVTAG can provide us with information on how these compounds go from gas to particle and particle to gases with temperature changes. Since we have a big temperature difference in here in Fairbanks from outdoors and indoors, we have a lot of these dynamic back and forth between gases and particles. So we can also estimate which pollutants goes from outdoors to indoors, and we can also quantify how much of these pollutants actually infiltrates to our homes. And why do we care about all this? Why do we measure all these compounds in such a specific phase level? It's because depending on the chemical composition and the phases and how much we have in each phase, they're going to affect our health or climate differently. And that's why you're trying to understand here in this extreme weather in Fairbanks. So this is like a little summary of the instrument, and I'm happy to answer any questions if you have later on. But that's the SVTAG.
Thank you, Carol. So we just heard a little bit about one instrument that does both measurements in the particle phase and in the gas phase. And now we're switching on to an instrument that only measures particles. And so that's the aerosol time of flight mass spec. And was Andrew, I think Andrew is going to give the overview of this instrument. So Andrew, take it away.
As Pete just said, my name's Andrew, and I'm a part of the Pratt Research Group at the University of Michigan. The goal of all of our research is to really understand the chemical interactions between trace gases, particles, and then clouds and snow as well. To do that, we use a variety of different instruments. The one that we're using for this study in Fairbanks is the Aerosol Time of Flight Mass Spectrometer, or ATOF-MS. And the reason that this instrument is really so cool and so powerful is it gives us the chemical information of individual particles that are moving through both the outdoor and indoor environments. And what I mean by that is aerosol particles move into our sampling lines and then are blown up by a laser, basically giving us a chemical fingerprint for each of the individual particles. And from that, we can really understand where these particles coming from, whether that be coming from the snow removal of a diesel engine, whether that be coming from your car exhaust, even could be something as simple as burning wood and giving you smoke. So really this instrument can give us the size and chemical composition of aerosol particles in the atmosphere and really help address the issue of where is this pollution coming from. I'm happy to take any questions that anyone has.
Just to pause for a second, I see there is a question in the chat from Jim Brader asking, how do you keep cold particles from outside from changing their phase before sampling in the garage? So this is our...
I think that was for me.
Yeah.
Yeah, so I don't know if Alice can show the cooler that's mounting on the garage door. So yeah, there is a cooler that is mounted in the garage door in which we draw air from outside and we keep our sample lines outdoor in that cooler. So from there, we just go very straight to the instrument so we can keep things as they are from outdoor before going into the instrument. So inside the cooler, we have a line that is a denoter that has a denoter that can take the gas phase out of the sample, and then we can avoid. And then after that, we really don't care what's going on because we already characterized what was in the gas and particle phase that was outdoors. So that's how we came up with a solution, since there's such a big difference in temperature.
I think Ellis is on deck now for the aerosol mass spectrometer. So sticking with particles and measurement of particles. Ellis, take it away.
Yep. So thank you, Pete. Yeah, I guess some other people have introduced the idea of mass spectrometers. I have another one. This one is sort of powerful because it operates in real time. It allows us to get data points sort of as quickly as we want. We're taking data every 1 minute to sort of get some robust signal so that our data don't look too noisy. I can just paint a picture for you a little bit right here. A lot of my day is filled with watching data come in on the screen. You can kind of see the traces, okay, but that's again the difference between outdoor and indoor. And the aerosol mass spec, it, like Andrew's instrument, it blows particles up. Once we blow them up, we can attach, or we can shoot electrons at them and sort of make the bits of those particles charged. And once they're charged, we can use electric fields to shoot them around and make them land on a detector. And the detector sort of tells us how much of those particles there are. One of the big challenges with all of this work is being quantitative. So quantifying exactly how much of any given particle type is in the atmosphere is always a challenge, and the aerosol mass spectrometer does a good job of quantifying sort of the major components of atmospheric particulate matter that are around, such as organic aerosol, sulfate, which you may have heard of, nitrate, and so on. And so I guess to sum up, with really high time resolution, we can quantify almost all species that exist as particles. It can do some other stuff too, but that's some of the real power and that we have with this instrument. And comparing what the composition of the indoor particles is from the outside will, be my job for months after this to look at all this data coming in.
Thanks, Ellis. So far we've talked mostly about instruments that make direct measurements and give you real-time feedback on the data. But there's also instruments that we have at the house that do what are called integrated measurements, which means they collect things for longer periods of time. And so talking about that type of instrument is Sukriti from the University of California, Irvine, and some of the measurements they're doing of particles using this longer time integrated measurement.
Hi everyone, I'm Sukriti. So I'll be talking about the measurements we're making at the house. So we basically have two instruments for indoor and outdoor measurements. So for the outdoor measurements, we have a high volume PM 2.5 sampler, which we collect for about 23.5 hours. And this is how the filter looks like post collection. Whereas for indoor samplings, this is our cascade impactor, which collects size separated particles. So for different indoor activities, like Pete mentioned, we are collecting on filters like these. And we will be taking our filters back to the university and using this instrument, the electron paramagnetic resonance, to basically analyze the reactive oxygen species that we have in the particulate matter, because these play a very important role to be for human health, and they impact our cardiovascular system and the respiratory system. So that's pretty much about our measurements, and I'm happy to take questions. Thank you.
Thank you, guys. That was really great. And I think just to kind of sum up all of the measurements that we're doing, something that I like to tell people is, we have our own detectors as people. We have noses. Sometimes we can taste pollution. Sometimes we can see pollution. And so all of these fancy instruments that we talked about in the garage are ways that are a little bit more precise in measuring exactly how much or exactly what chemicals are present. And so they go beyond kind of our natural detectors of our nose and eyes to make really detailed measurements of what's going on. So we're very happy to be here and to be able to do this. And we really look forward to hearing from you guys, hearing what questions you have. If there's anything that we can try to answer with these measurements while we're here, we'd love to try to do that. So please let us know what your thoughts are, what your concerns are, and how we can go forward.
Yeah, so we have, I saw one question come through, which was from Hiyo, and he was asking, can you tell apart local, street, neighborhood, drivers of air aerosol particle composition and large-scale Fairbanks interior Alaska drivers? If so, how?
I could try to take this one. Hi, Hiyo. So with one of the things that we're doing here is we're making these really detailed measurements, many of which can tell us about the sources of the particles and the gases. And so that can help tell us about power plants versus home heating versus the transportation sector. So you might think of it as the different sectors of the energy sectors versus, we even measure things like road salt, which was applied, I think, recently when it was warm, we noticed. And then we also, there are people that are part of this study that are doing air quality modeling associated with the Environmental Protection Agency. And that work also can help us understand and integrate our measurements with also the air quality simulations to help tell us about what is from further away versus what is local. And then I think another person who could also build upon this question is Ellis, who has been driving around a car all over Fairbanks. If you wanted to mention that briefly, Ellis.
I'd also mention where you're from, Karrie.
Oh, sorry, I'm from the University of Michigan.
Sure, yeah, so like Karrie just mentioned, I've been doing some mobile sampling with some instrumentation that fits in the front seat of my car. I've been driving a loop around Fairbanks and doing that sort of repeatedly at different times of the day, but going by the same places over and over again. And so, if you do that one time, it's sort of potentially an interesting snapshot, but you can have, maybe you get caught behind one of the big snow removal machines. And that's a source of pollution, to be sure. But if you were just sampling behind that for an hour, it wouldn't be very representative of what the air in Fairbanks is like. So the idea is to go back to places over and over again, and through those repeated visits, all those snapshots sort of add up, and you can create a spatial picture of what pollution looks like here. And that's been important because we have this house site, but we also have a site downtown. And so it sort of provides context and lets us stitch together a little bit our picture of the area, because we've already seen that the spatial differences in air pollution here in Fairbanks are such that the house site is not measuring the exact same kind of air as the site downtown. And so back to the earlier question, we use a combination of all these different things, mobile measurements to give a spatial picture, and then chemical signatures of different types of pollutants, the modeling that Karrie mentioned, all of that sort of feeds together to help us understand local sources, more regional scale pollution and meteorology that all works together to influence the air.
Bill, oh yeah, go ahead.
I wanted to say that Ellis did mention that there's another site that's downtown, and we do know that downtown Fairbanks has a bit of a different mix of pollution than the neighborhoods, than residential areas. There's steam heat downtown, there's more car driving, there's less, say, wood heat in downtown area. So one of the cool things is there's also state-of-the-art instruments down there, and in 2 weeks we'll have another one of these open houses with the instruments down there. And the comparison there will help us to tease out different sources, because the mix is very different at those two locations. So I'm advertising in 2 weeks, come back to the same time, another one of these open houses.
Bill, I might just add to the last point, one last comment. I think everyone answered really well, but I'm Brent Williams from Washington University in St. Louis, working with Carol, who presented earlier. One of the ways, a telltale sign for us, regardless of any of these instruments, whether it's a local source or kind of a regional source, is is sort of the temporal information. A very close source will be really high concentrations for a very short period of time, and a very spiky data, as we would call it. More regional or sources that are further away, if we're being impacted by them, it tends to sort of raise the baseline of our concentrations or of our pollutants for a longer time period, maybe for a day or 2 days or 3 days, depending on the meteorology. So that's another way of sort of teasing out the data as we go back and look through it to figure out what's very close versus what's farther away.
Looks like we have a hand up from Mike.
Yes, thank you so much. I was just curious if you guys are tracking any of the thermal inversion activity in conjunction with this, and if that's—
Bill can probably speak to that.
Yeah, thank you.
Sure. Yeah, you've hit the nail on the head that inversion is a really important thing for Fairbanks pollution. And so we've got a real big focus on understanding the inversion. At the downtown site, you'll hear more about that, but we have different ways. There's a balloon that people may have seen that's operating over near UAF that's vertically sampling the atmosphere. But additionally, we have temperature sensors at different altitudes on the CTC building. And so we can see very strong inversions across the CTC building in this last pollution episode. It was 9 degrees centigrade warmer, which is probably about 15 degrees Fahrenheit warmer at the top of that building as compared to the bottom of the building, which is incredible temperature differences over such a short length scale, about 80 feet for that building. And then we also have monitors up on Birch Hill, and we're using a remote sensing technique to measure pollution in the vertical over Fairbanks, and thereby understand the relationship between the trapping of the pollution and the temperatures that are out there, the thermal inversion. Okay, so we've got a few, there was a question about the timing of the study, and it seems like that's kind of being handled in the chat. Is there more to say about that, Ellis?
I mean, you guys can talk to this better than I can, but you know, this project has been in the works for years and years. And it was going to happen last year, and then it didn't. And it almost didn't happen this year, but I think everyone sort of came together in a really good way, and we made it happen. But just to respond to what Owen asked, what is unique in Fairbanks exists when it's coldest and darkest. And so that's why we wanted to be here at this time. We didn't get the absolute coldest and darkest, but we're definitely getting that behavior even over the few weeks that we've been here so far. So I think we'll be able to learn about the cold and dark times from our study.
Liz Grieg has a hand up. I think you can unmute.
Yes, I'm sorry.
No worries. Go ahead.
So do you have an open house downtown? I work downtown and I live in Hamilton Acres. And Hamilton Acres is one of the most polluted, consistently high levels in Fairbanks. But I work downtown. Anyway, I got off the bus this morning right in front of the news miner. And I was going to take my mask off because it's easier to breathe. And it smelled so bad, I just put it back on again. So did you notice any difference this morning right there at the Cushman Street Bridge?
So the monitoring site we have is at the CTC building, 604 Barnett, which is the old courthouse. And yeah, and so that's sensing that air that is downtown, and we've been taking lots of measurements, and it was very, very polluted. The inversion has been strong for something like 5 days. It broke this afternoon, and the winds that were aloft came down and swept away a lot. So it's cleaned up recently, but it really got to be a pretty bad pollution episode with multi-day pollution. So we'll have a lot more to say about the composition. I did want to say one thing that's so cool about this study is that a lot of the things we've known about pollution in Fairbanks in the past have come from long-term filter samples, like 24-hour filter samples, to get the composition, the chemical composition of the particles, which helps us to fingerprint sources. With these instruments that these investigators have brought here, it's incredible. I mean, we go to minute timescales to get the same information we would get from those filters. And as some have said, that allows us to separate out like what the pollution looks like at drive times, what the pollution looks like at times when people are cooking dinner or in the evening. So you can look at different behaviors and look at the time variability in addition to looking at just the chemical composition. So it's really going to make a revolution. And we've also never really been able to know what are in the gases. And some of those gases are pretty bad to breathe. Benzene, toluene, compounds like that you don't really want to be breathing. And so those measurements are going to help us to understand what makes those bad smells, and hopefully we can look at how toxic they are too. What are the health effects?
You mentioned an open house.
So it'll again be a virtual open house. Of course, this is going on under the time of COVID. So we have a pretty strong COVID mitigation plan where we are all masked up, and Ellis in the garage there is alone, so he can be unmasked. But generally, we're not able to have a physical open house because of the COVID restrictions. So that second one will be a virtual open house just like this.
So it's only one day for an open house?
It'll be a Zoom session just like this at 7 p.m. 2 weeks from now on the 17th is that virtual open house. So on a normal year, we would love to have you all over and come on in, but it really just, one of the things about this study, there's 4 dozen or so people here, and every one of these people knows how to run their instrument, and essentially nobody else knows how to run their instrument. So we can't have anyone be getting sick because it would shut down one of the instruments essentially.
No, that's not what I was getting at. I was really thinking about how to access information, say from today all the way through to the next 2 weeks, or is it just today and 2 weeks from today? And that's it.
We'll be talking about those measurements, but then after the fact, we'll be out in the community giving talks about what we found and writing scientific papers and communicating through the Fair Air site our findings. And we'd really like to also work with community members who are interested in this topic to hear our results and to be able to translate those and communicate them back to the public. So really, a lot of the questions we're asking came from the public. People said, we're indoors a lot. What's the air like inside? Is it cleaner? What can I do? So trying to answer those questions.
And let me follow up on that too, and say that I think a lot of the field team is also very excited to come back to Fairbanks when it's not minus 30 outside, and we can see the beauty of the other seasons of Fairbanks too. And so all of these really fancy instruments, while they do provide us real-time feedback and real-time data that we can look at, we still have to go, and there's been some talk in the chat about how we do calibrations and things like that. It's going to take us, 6 months to really analyze that data to a point where we're comfortable with the measurements that we made, because these are much more complicated instruments than the type of things that you use from a regulatory perspective. Like the 24-hour measurements that Bill was just talking about, those are more straightforward to analyze. The data that we're getting, both at high time resolution and with all of this additional chemical information from these, mass spectrometers looking at 100 different molecules in the gas phase and 100 different signals in the particles, we to understand that and take all that information and do some of the source identification that we were talking about before, it just takes time. So we have every intention of sharing all of those results with you, but it's going to take us and our teams, some time to get that to the point where we're comfortable with the results of the data, because being scientists, we're very particular about our data and we want everything to be just right. So, but we're excited, and we're excited to share that with you. And I, for one, am excited to wear shorts in Fairbanks, and not 7 layers of clothes. So
yeah, it's February.
I see Mike Kraft has a hand up again.
Yes, thank you, Bill. Sorry about that. I don't mean to hog the conversation. I just want to say thank you to all of you for coming to Fairbanks and doing this. I've lived here 41 years, and I have 6 grandkids that are growing up here, and they go to Wood River Elementary, which is in one of the low-lying areas in Fairbanks, and I am scared to death for what's maybe happening to my grandkids. And I just want to say thank you, and if there's anything I can personally do to support your efforts, I would do it in a heartbeat. So hats off to you guys. Thank you for coming to Fairbanks.
Thank you for the interest. And yeah, we really are interested in communicating this and sharing what we're doing. I saw there was a question by Jim Brader earlier about quantitative and qualitative measurements. Each group has their own, but pretty much these are very quantitative measurements. These are very quantitative numbers about our air pollution and getting indoor-outdoor ratios. So there's a lot of quantification here. I think Pete at one point said you can, notice these things by smells. Your nose actually desensitizes, and you start to get used to things. And one of the good things about our instruments is that they can really quantify how much is there, and they don't do what your nose does, which is get used to some potential problem in the air in your house.
Liz, do you have another question?
The specific question I have relates to PM 2.5 or whatever it is that you're measuring and you're going to find out about, and the incidence of type 2 diabetes. I've done some reading about it, and I've heard somebody say that she was denigrated by her medical professional, and I'm wondering if there are any of you who are studying that specifically and not just simply breathing issues.
I mean, so I don't know if that any of our groups are particularly studying the links to some of the health impacts. There are many other groups at other, in schools of public health and groups that I work with that do look into these types of linkages. But we're much more on the, I guess, the analytical or the measurement side. And so our information can start to feed into those types of studies, but it's not something that we collectively as a group do. But I think those are the types of questions that often motivate the type of research that we do. If we can understand the concentrations, and then there are hospital records that other people maintain, and they can start to look at linkages between the chemicals that we measure and medical problems that people experience based on those concentrations. So it's certainly something that hopefully our measurements can help inform, but it's not something that any of us, I think, are doing specifically right now.
Yeah, and you're correct that there is an association between type 2 diabetes and particulate matter that's less than 2.5 microns. And so just to add that, even though we aren't studying that association in Fairbanks during this study, one of the things with a lot of those health studies is that they don't always know where the particulate matter came from. And so therefore it's hard. We can say that there's a problem, and we know generally that high levels of air pollution are a problem for human health and for many different reasons for our health. But we want to understand, why is the air quality bad in Fairbanks, so that we can help to provide suggestions of how to improve the air quality, which will then help improve the health of the citizens in Fairbanks.
One thing I may add on to that too, with respect to the indoor-outdoor study, is, we want to know about indoor sources. We want to know also about how much air infiltrates into the house. Are there things you can do with, say, air filters in a house that can clean it up? So we want to try to understand both outdoor air quality, which is, of course, as Pete said, regulated, and what people can do about it to protect themselves indoors, or just understand the differences between indoors and outdoors, which is, I think, important to us here in Fairbanks. I see Marianne Nichols has a hand up. You can go ahead and speak.
I wanted to mention that quite a few medical providers have put filters into their offices, and I think it's probably a requirement, but if they're doing it on their own, that's great. So is that, how much wood smoke can get into a house and how?
That's the question.
That's the $100 question, I think, and that's an inside joke with the group here, because we just had the stove that was installed checked, and apparently the technician used a $100 bill to check some of the leakage. So I guess there's two parts to that question. The first part is how much wood smoke from outside, which is one of the components of outdoor air pollution, because most of the smoke is going to go out through a chimney. How much of that can get inside through infiltration? And that's one of the questions we're trying to ask. But then we're also interested in the question, if you have a wood stove, or if you, in our case, we have a pellet stove in the house, when you use that, is some of that combustion, most of it's going outside, but is some of it coming inside? And if so, how much, and how does that impact things? And so it's a question that we're trying to answer. We only have one house, and so we can't have, we can't have 5 different wood stoves that we're sampling and 5 different pellet stoves, which we'd love to be able to do that. But, we're limited in how much we can do. Trying to move that garage and all those instruments to multiple locations would be really difficult. But certainly that first part that I mentioned, how much outside wood smoke is coming inside, is a question that I think we can get a pretty good answer on for the house that we're in. And then with the one pellet stove that we have, we're exploring that second question of how much, when you use a pellet stove, how much can come in the house, and what does that look like? Again, inside is 60 to 70 degrees Fahrenheit, and outside is not. So does the chemical makeup of that smoke change because of the temperature difference between them two? And so those are the other kind of really interesting scientific questions for us to investigate.
But are the air filters that I see in a medical office, do they take care of PM 2.5, or are they designed for other things?
They're mostly designed for particulate matter. So if they're like a HEPA grade filter, then almost all of the air that goes in, almost all the particles are going to be removed if they're a HEPA level filter. If it's a lower grade filter, you remove some fraction of them. And similarly, in your, the home that we are making our measurements in has a forced air system. And so we can pull air through the house through a filter. And so the filters that you have in a home system aren't going to be HEPA grade, but the higher rating of that filter, the more filtration you get out of that, you remove particles with every pass through that filter. And so one of the things we are going to explore is, if you change from a low grade filter to a high grade filter, how much does that help the indoor concentrations?
I have another question. I look at purple air fairly frequently. And where I live, there's a purple air measurer monitor close to wood burner, but it only shows spikes when I look at it. And so to call an alert, it has the spikes, maybe the time of day people start their stoves, coincides with an inversion that's from the weatherman or the meteorologist?
I think that one of the analogies you might think of for thinking of this one purple air sensor and what it's measuring is if, say, in the summertime, you're around a campfire and the smoke, the smoke will change directions. And so whenever I'm around a campfire, a bonfire, or a fire pit, it's almost like hot potato. You're trying to figure out which seat to sit in so that you're not in the smoke. And so those are those spikes. So if you have a purple air sitting in one location, it will get a spike. It will spike when the smoke goes over. But so as the air moves, even when the air is fairly still, the air still moves. And so you can think of that it's as those spikes going by the smoke, like from a fire.
Does this
we'll notice
put out more pollution as it started?
Yeah, so the startup of a stove when it's cold does lead to extra pollution coming out. And so one thing that I was going to say about the purple air network and also about indoor air is that if you look at the purple air, there's one downtown near the Tanana Valley Clinic, and there's an indoor air quality sensor in the Tanana Valley Clinic. I believe in the purple air site, they have black circles around, a dark circle around ones that are indoors. And it's impressive how good the air handling is on that building. The air is typically very clean inside that building. So you can clean up air with good filters. It's not, it definitely takes some work and some investment. And there was a question from Owen Hanley about, does the test house have air filtration or exchange? It does not have a heating recovery ventilator, HRV system like some houses have. It's a fairly, we had hoped for a kind of generic average Fairbanks house. We had it energy rated, and it's probably rated towards the top of the 3-star, bottom of the 4-star rating. So fairly tight house, fairly well built, well maintained, but not an extreme high or low. I'm gonna check to see if there were any questions which came in on Facebook. It doesn't look like there were. Potentially Kelly or Krista, no Facebook questions. Okay, good. Well, great. I think this was a really exciting event, and it was great to get this big tour of the garage there and see what's going on. And I saw Karrie Pratt's statement of we're honored to visit, and we are. We're really thankful that Fairbanks is hosting this event and this field study, and really want to work with the community to try to get the information we find back to everybody in the community. So I do see one last question here, which is, oh my gosh, a big question just came in. I see one last question that we can probably deal with, and then we'll take other questions. And what we'll do is on the Fair Air website, we will put up a thing after this with the video, I guess, and we can also have the questions that were asked. And if anybody does put in any more questions, we'll reply to those questions. So I see one, which is, could a study of the efficiency of HRV retrofits be done? And I think that's a great idea. In this case, we really couldn't move to different locations or do too many changes to the house. So we really had to pick which questions we wanted to ask and try to answer here. Another thing that's really important is houses vary a lot. So it would be great to do a study with a lot more houses than this so that we could get a bigger picture. So any of the presenters, Pete, last words?
I wanted to say thank you to Fairbanks for being a great place to come and do this type of study. As someone who's made measurements kind of in a lot of different places, this is very, very unique. Most of our air quality projects that I've been to tend to be in warm summertime locations. And so this is a very unique and exciting study. And Fairbanks is a great city for us to come visit. So thank you all for your hospitality. And we're looking forward to digging in and visiting again once we have a little bit more of this data analyzed.
Don't forget, Saturday is the start of the Yukon Quest. While you're here, you might as well enjoy it. It'll be a lot of fun.
Thanks so much. Okay, great. Thanks for coming, everybody. Again, in 2 weeks, we're going to have another one of these events that's showing the instruments that are in the CTC location, and bring your questions to that session too. So thanks so much, everybody.
Thank you.
Thanks again.
Thank you.
Okay, everyone.
That's all.
Thanks for coming and doing the study. I appreciate it. We all do.